Good morning and welcome to the Z Exchange. Thank you so much for joining us today. I'm going to go over a few notes before we get started on the presentation. My name is Sammy. I am representative of the Z Exchange as well as an employee of New Era Software. We ask that during the session, if you have any questions, feel free to put them into the Q&A. I will try to get to them as they come. If I do not get to them during the presentation for any reason, we will have a moment at the end to go over any questions you have, so feel free to put them in as we go. We will also be sending out an email after our presentation today. It'll have the ability to get a recording. You can get a link to the recording to this presentation so you can share it, rewatch it, or revisit anything that you wanted to check out again. And if you wanted additional information, you can reply to that email or contact me directly. That being said, I'm going to go ahead and move forward. I'm very excited to welcome Greg Boyd today. He's diving into the latest crypto enhancements coming to the IBM Z platform. With more than 40 years of experience in the IBM mainframe world, Greg's become one of the community's most trusted voices in IBM Z cryptography, education, and security through both IBM and mainframe crypto. So why don't you go ahead and take it away, Greg?
Thank you. Let me do the share first, and make sure I get the right one here. So hopefully you can see my slides and you can see that I changed slides and you can hear me.
Yes.
Okay. And I'm also going to turn my video on briefly, just so you can see that, yeah, I really am a person. I'm not an AI bot that's manufacturing this. So we're going to talk about the crypto update, what's new in the IBM Z crypto world. Let me go ahead and turn the video off because that distracts me. So for those of you that don't know me, I'm Greg Boyd. I spent a little bit over 30 years with IBM. The last 10 to 15 years of that, I was in what was then called the Washington System Center, and it was my job to help customers and IBMers understand the Z crypto technology. That included the hardware and the software and the products that leverage that software. I considered all of those fair game. Left IBM in 2014 in one of the purges. I fortunately was able to retire, and I started my own company, Mainframe Crypto, basically doing the same thing that I had done for IBM, but just as an independent contractor. So I would, and there was a little bit more of an emphasis on hands-on at that point. I was able to help customers directly do some of the things that they needed to do with the crypto technology. In 2021, IBM Lab Services reached out to me and invited me to come back. And I came back with two conditions. One, that I could work part-time, and I can highly recommend part-time retirement work. And the other was that I could continue in this role as mainframe crypto. Now, my agreement with IBM is that I can do education and training and sessions like this as mainframe crypto. The consulting work that I do is all going to be done through lab services. So, with that said, I'm presenting not as an IBMer today, I'm presenting as mainframe crypto. So, we're going to be talking about publicly available information. You're not going to get any IBM secrets in this session, but we're going to talk about stuff that's been published and that the world is aware of and the new stuff that's available. And specifically, in the last 2 years, 2 years ago, IBM announced the Z17, and that has some new capabilities in terms of the hardware. And then we also now have ZOS 3.2 with a new level of ICSF. So we're going to talk about some of the enhancements that came with that as well. And then briefly, I want to talk about tape encryption at the end because there's some new information there as well. So on slide four, the Z17 hardware, like all of the Z boxes before it, comes with a built-in hardware, the CPAC-F or CP Assist for cryptographic function. Basically, that just provides some additional instructions on the motherboard, if you will, on the chip that are available to your assembler programs. IBM calls these instructions. Well, first of all, it's a separate device because IBM there are export restrictions associated with cryptographic capabilities, and IBM can only send that technology to certain countries, certain entities. And so the way that IBM handles that is it's a separate piece of hardware. There is a separate feature code that has to be installed on your KEC to enable this technology. And again, once you have it enabled, now there's some assembler instructions that you can invoke and execute on the hardware to perform cryptographic functions. IBM calls those instructions MSA or Message Security Assist instructions. And pretty much every generation of KEC, going all the way back to the Z990 and the Z890, has had a new support in it, new MSA levels. And that's true with the Z17. And in fact, there are four new MSA levels that are available on the Z17. The first one has to do with fully implementing XTS or ciphertext stealing support. Ciphertext stealing is just a way of doing encryption, blocking, and chaining things together to provide better security. Now, you could do at full XTS prior to the Z17, but there was the instructions, the hardware didn't fully implement it. So there might be multiple trips to the hardware, ICSF having to be involved to fully implement it. So what you get with this full XDS support is uh, uh, we would expect some performance benefits when you're doing full XTS encryption. And it's important to note that XTS is the technology that's used for data set encryption. So if you're enabling pervasive encryption and specifically encrypting your data sets through the operating system, there's going to be some advantages on the Z17. Eventually, IBM will probably publish a white paper on performance of cryptographic operations, and hopefully at that point we'll see some of those advantages. The second MSA level, MSA 11, adds some support to an existing instruction, the KMAC or Compute Message Authentication Code. It will calculate an authentication code for you, and now it can support HMAC operations as well. MSA 12 has to do with the existing instructions for hashing, computing digest, whether it's the intermediate or the last message digest. Those instructions have now been enhanced, and there's some capabilities in terms of being able to automatically apply an ICV value or a chaining value of binary zeros. And that's implemented for both SHA-3 or the shake hashing operations. The last MSA level here, MSA 13, affects all of the instructions, all of the MSA instructions going way back to the beginning, and they have all been enhanced. So now you can query the instruction, query the hardware, and determine the microcode or the firmware level that's running in that for that instruction. And the idea here is there's a lot more auditing requirements to make sure you're using the appropriate algorithms and the appropriate generations of algorithms. So with this enhancement, now you can query your hardware and say, hey, yeah, what firmware level are we running when we're running this instruction? So that's it for the CPAC-F hardware. I forgot to mention, although Sammy did in the introduction, if you've got questions, please feel free to ask them as we go along. I may not see them in the chat, but Sammy's going to interrupt me and we'll address the instructions or the questions as we go along. So feel free to chat. Um, Turning to the Crypto Express cards, the Crypto Express cards are an additional feature that you have to order separately. If you want them, you have to order them. The Crypto Express cards have been around for years. What's very different on the Z17 is it is using the same Crypto Express 8 feature that the Z16 used. Prior to this, every other new generation of KEC also had a new generation of the Crypto Express card, the coprocessor. So Crypto Express 7s were available on the Z15, Crypto Express 6s on the Z14 before it, and so on. But for the first time ever with the Z17, you're using the exact same feature that you did on the Z16. Now, the Crypto Express 8 card on a Z17 is running a later version of the CCA software. So there are changes to what the cards can do, but it is the same technology. The 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 major difference between the Crypto Express 8 card on the Z16 versus the Z17 isn't really a technology function, it's documentation and wording. What happened is after the Crypto Express 8 card was introduced on the Z16, the IBM had implemented in the cards some of the new QSA capabilities that were coming down the line, and they introduced those even though they had not been formally adopted as standards. And what happened between the Z16 and the Z17 is NIST, the National Institutes of Standards and Technology, have accepted these algorithms and certified them as being good technology, good things to do. So what IBM used to call Crystal's Kyber is now called MLKEM, or Module Lattice Key Encapsulation Method. Um, it has been standardized as FIPS 203, and now on the Crypto Express 8 cards on the Z17, IBM has formally changed the labeling to say, yeah, we're using that formal standard. Similarly, Crystal's dilithium was a digital signature algorithm that has been formally accepted as FIPS 204, and it's now referred to as MLDSA, or Module Lattice Digital Signature Algorithm. So a lot of what's in the manuals are just cosmetic changes to change the label that's associated with those. It looks like there are a couple of the APIs that may have been changed slightly in terms of key links and some of the parameters that are passed to it to formally map to those FIPS 203 and 204 standards. But for the most part, it's just a name change. Now, the other new capability on the Crypto Express 8 card is we now have support for 8192-bit RSA keys. If you've been following the quantum discussions about cryptography and how things are going to become more vulnerable, longer key links are stronger. So way back in the beginning of time, RSA used 512 and 1024-bit keys. Those are no longer considered secure. 2048 or even 4096 are what most people are using, and the next turn of the crank would logically be 8192-bit keys. Now, those longer RSA 8192-bit keys aren't going to provide a huge value when quantum becomes a reality, and those prime numbers can be reversed and that key material calculated. But for now, if you want to use RSA 8192-bit keys, they are supported in the hardware. The Crypto Express 8 card configured as a CCA coprocessor has been submitted for FIPS certification, so it's in the process of being FIPS certified, and I'm going to talk about that again a little bit later on in the presentation.
Greg, we did have one question come in.
Yes,
Um,
ma'am.
do you know if CCA v8.4 will be supported on a Crypto Express 8S card installed in Z16?
That is a great question, and I'm not sure of the answer, so I don't think I'm going to try and answer it here. But if you will send me a note, Sammy, I will research that.
I sure will, and we'll get back to you on that.
I suspect the answer is yes, but I should verify that before we go any farther.
Perfect. Thank you, Greg.
You can also configure those Crypto Express cards in EP11 mode to support PKCS11 operations. And just like on the CCA card, the EP11 cards can also support those new approved algorithms, MLKEM and MLDSA. So the APIs and all have been updated. You can uh, reference those algorithms and use those algorithms on the EP11 cards. The EP11 card, the original EP11 card on the Z16 has been FIPS certified, although at the FIPS 140-2 level. That goes back to 2023, and then it was updated last year as well. But again, I'm going to talk about that a little bit more in a couple minutes. We're going to look at FIPS a little bit more closely. And along with adding that QSA support in the hardware, like I mentioned, the APIs have been updated to reflect those new standards. The PKDS keys utility that's available on the ICSF panels has also been updated. So now you can use it to generate MLDSA or MLKEM keys, either one. So this PKDS keys utility, you're not going to use it to generate lots of keys and production level keys. However, it is a handy little utility if you want to try things out and you want to try using a DSA key or a KEM key. You could use this to create one and then maybe invoke the APIs and use develop some Rex execs that would use the APIs with those keys. So that's been updated. I'll also mention that out on the IBM community page, there is a blog, I guess, out there that has a sample Rex exec that will drive the process of creating a hybrid QSA scheme. And the idea here is if you want to create some keys to protect data, historically, you'd use something like Diffie-Hellman. Well, now we can create that operational key using a QSA key as well as an RSA or ECC key. And just by virtue of the fact that a QSA key is involved, that would be significantly more secure. So there's a Rex exec out there that you can play with that would generate the key material for you using that hybrid scheme. That's it for the hardware. So now we're going to talk about the changes, the new capabilities in ICSF itself. Now, this first one I think is related to the hardware. It's a new ICSF option called Max Slow Ops. Now, the ICSF option data set is a ParmLive member that describes your configuration, the parameters, if you will, that ICSF is using when it comes up. So you have things in there like the names of your key store, the pointer to your CKDS, a pointer to your PKDS. There is a new parameter that you can specify there called max slow ops. And it is the maximum number of slow operations that you can run simultaneously on a CCA coprocessor. If you did not realize it, the Crypto Express cards can actually support multiple threads. So you can have up to 8 units of work being executed on the card in parallel. Well, this parameter is going to control how many slow operations you can have running at any given time. IBM does not define what they mean by slow. They do give an example to say, like an RSA key pair generation. So my suspicion is that this parameter setting can be used if you need to ratchet up the number of 8192-bit key generations you can do in parallel. Uh, Key generation for 4096-bit keys can be expensive. 8192-bit keys are going to be even more expensive. So you might want to take advantage of this if you need to get more of those key operations through in parallel. This parameter setting is displayed on the ICSF options panel. So if you go into ICSF 3.1, it will show you the options settings. It doesn't show 100%, but it shows a lot of the option settings. And this parameter is now displayed on that panel as well. So now let's talk a little bit more about FIPS. If you're not aware, FIPS 140-2, which has been around for years, I think it goes back to the early 2000s when I started. FIPS 140-2 was the standard. That has now been replaced by FIPS 140-3, and you can think of it just as a new and improved generation of FIPS 140-2. So this standard has to do with the security that goes around your cryptographic modules, whether it be hardware devices like the Crypto Express cards or whether it be software devices, algorithms that are executed in a software module. This FIPS 140 describes the security that you have to have around those modules. And it with FIPS 140-3, it has simply been updated for the latest and greatest technologies that are available. So it conforms with the ISO standards, and it just defines the security packaging. If we go to slide 10, some of the things that they evaluate, this list of things that they evaluate is pretty much the same list of things that were evaluated with FIPS 140-2. It hasn't really changed. What has changed is some of the requirements of what physical security means, or what roles and services and authentication mean, etc. So in terms of physical security, the hardware crypto modules, they can be packaged and they need to be packaged. We'll see it on the next slide with either tamper evident capabilities or tamper responding capabilities. The physical package needs to provide that. Roles, services, and authentication. At the lower levels, you have to have a minimal authority to do something to the cryptographic module. At the higher levels, you have to not only have a role assigned to you, but then you have to authenticate, and that ID that you authenticate has to have that role assigned to you. So, for example, if you needed to update the cryptographic module, if you needed to install MCLs in the module, you would need to have a role that has the authority to do that, whereas other roles would only be allowed to use the technology. So this FIPS criteria defines those definitions. On slide 11, um, both FIPS 140-2 and FIPS 140-3 have different levels of security, and they're additive. So level 4, you have to the crypto module has to have everything that was required in levels 1, 2, and 3. So level 1 is pretty simple. It basically is just saying that you're using technology that is for a formal product. It's not beta code. It is a formal product that fits within the architecture of whatever system you're running it on. It has to use FIPS approved algorithms. So going back to the MLDSA and MLKEM, to be FIPS 140-3 approved, you have to be using some of those levels. Similarly, there's a standard for AES, there's a standard for RSA, there's a standard for ECC. You've got to be using those approved algorithms, and they have to be implemented according to the algorithm specifications. At level 2, we add in role-based access. You have to authenticate and say, yeah, I have the authority to do this. Level 3 takes it up a step farther. Now you've got to have an ID assigned that has the role. There's also some additional physical security requirements. So now we get into the tamper evident packaging so that if somebody tries to stick a probe on the card, it will it will be easy to tell that they did that. Level 4 takes it even to a higher level that says if somebody tries to penetrate the card, probe the card, not only are we're going to break, we're going to zeroize the card, and for the Crypto Express cards, that means they are bricked. They are no longer usable when a tamper happens. Um, Back to level 3, there's some environmental protections. If the temperature of the card gets too hot or too cold, that could be an indication of somebody trying to tamper with it. And if it exceeds the bounds that are allowed, the card will disable itself. And then lastly, I want to go back to level 1, the power on self-test. When these modules are initialized, they have to go through some internal checks. So, for example, they have to perform an AES encryption operation on a specific string using a specific key and get the expected results. And if they don't, the card should surface that. The module should say, hey, there's something wrong here. I'm not getting the known answer test that I'm expecting to get. So that's all wrapped up in this FIPS 140-3. You've got to meet certain requirements to achieve these various levels. So with that said, I want to go through some of the cards that IBM has available and the certifications that are available. The very first one there is for ZOS 2.4, and this is a software certification, so it's only level 1 certification, but ZOS 2.4, the PKCS 11 support within ICSF was certified as being FIPS 140-2 level 1 compliant. Now, 2.4, I believe, is way out of support, and that's why I've got it kind of darkened here. That evaluation, still exists. If you're still running 2.4, presumably that technology is still secured. It's just so old that the recommendation from NIST is, yeah, it's time to come into the 21st century and get on to more current hardware and software that provides this support. That line is going to become important when we talk about on the next slide, some of the information on the next slide. The Crypto Express 7, the 4769001 was certified as FIPS compliant in EP11 mode, and the Crypto Express 8 has also been certified in EP11 mode. That's certificates 4558 and 4553. The Crypto Express 7 coprocessor was certified in CCA mode as being FIPS 140-2 level 4 compliant. That's certificate number 4079. Typically, when a product is certified, it has a 5-year life cycle. That is, at the end of 5 years, that technology will move to the historical list. It doesn't mean the product is suddenly vulnerable or anything. It just means this is old technology. We haven't really kept up with it. You ought to look to moving into the 21st century and getting to some more current technology. The other thing that comes into play here is that with the availability and the switch to FIPS 140-3, NIST is going to move all of those FIPS 140-2 certifications to the historical list. Some have already moved, and the rest of them are scheduled to move in August of this year. So come August, 4558, 4553, and 4079 are going to move to the historical list. Once again, it doesn't mean that they're no longer secure. It just means, yeah, they're kind of old and you want to get up into the current world. So with that said, the Crypto Express 8 in both CCA mode and EP11 mode have been submitted to NIST for formal certification. And they are both in what is called IUT, or implementation under test status. That is typically the tail end of the certification process. So there's a lot of preliminary stuff that has to happen first. But even though, we're in the last stages of getting certified, there's no guarantee of the time frame. I can't tell you that either of those are going to be certified this year. They are simply in process. With that said, that technology has specifically been designed to be FIPS compliant. So, IBM was looking at the requirements for FIPS 140-3, what it means to be certified, and they have built those cards to be certified. My expectation would be if they find a flaw in the process during the evaluation, IBM's going to fix that and get the hardware certified. It's just we can't say yet that it has been. We can only say that the hardware has been designed to meet that compliance requirement, and the kind of the implication is at some point it will get there. We just can't say when. So now that we've talked about FIPS 140-2 and 140-3, I want to talk about the FIPS mode parameter in ICSF because it's changed in the latest version to add support for FIPS 140-3. So first of all, the first important point is this parameter setting only applies to the EP11 support in ICSF. It does not apply to the Crypto Express card when configured in EP11 mode. And in fact, they're to some extent mutually exclusive. So when you set the FIPS mode parameter in ICSF, going way back to when EP11 was first implemented and first certified, there were some settings there. You could say FIPS mode yes, no, or compact. FIPS mode no says there are no FIPS restrictions. If somebody wants to use a single DES key or a 512-bit RSA key that are not considered secure, hey, go ahead, let them. FIPS mode yes says, yeah, we want to enforce FIPS mode. We want to make sure that we want to prevent people from using single DES keys or 512-bit RSA keys. Now, in your environment, you might have one application that really does need to be secure and needed to be FIPS 140-2 compliant, but you might have other applications. Maybe you're, back in the old days, you were talking to a partner who was limited to double-length DES keys. And you really needed to continue that communication, even though you were using a weak key. So what compat mode did was it gave you the capability to enforce FIPS compliance for some applications while allowing other applications not to have the FIPS enforcement. So what you could do was you create this FIPS exempt profile in the CryptoZ class, and by virtue of having read access to that profile, you were allowed to use non-FIPS algorithms, non-FIPS key links. The other thing I want to mention there is the fail option. The fail option says when ICSF comes up, it's going to do some checking to see if it can support FIPS mode. It's going to do those known answer tests that we talked about a couple minutes ago. Well, what happens if a known answer test fails? What happens if for some reason the hardware is giving a bad result when it tries to do a FIPS encryption operation? The fail option says you could specify it as either yes or no. FIPS yes, fail yes said, that's a serious problem if I can't do only DES, or I'm sorry, only AES encryption. If that should fail, I want the ICSF address base to fail. Alternatively, you could say fail no, which says, yeah, if the known answer tests were not successful, go ahead and bring up ICSF, let it come up, and I want to do other, I want to be able to do other operations. I've got other production work that needs to run. My personal opinion is if there's a problem with the hardware and it's not generating good results, I want ICSF to fail, and I want IBM hardware, and I want people dispatched to figure out what's going on and let's get it fixed. Alternatively, yeah, I got production work that's got to get done. Maybe I would go ahead and let ICSF come up. So that was the original setting for the FIPS mode option in the options data set. Now that we have 140-3, we have some additional parameters that you can specify for FIPS mode, and they're kind of similar to what we just talked about. FIPS 140-3 enforce, that second operation there says, we have some pretty serious requirements here. We want to enforce only FIPS 140-3 technologies. We want to make sure that's all that we do. So the enforce option says, yeah, if somebody tries to use an older, weaker key, we're not going to let them do that. 140, the first option there, indicate, says, yeah, we still we want to do FIPS, but it doesn't necessarily have to be 140-3. There are some cases where FIPS 140-2 is still acceptable. So when you set FIPS mode 140-3 indicate, what you're telling ICSF is execute the APIs, and if you have to use, you're going to give me a return code that says the operation was successful, but you're also going to give me a reason code that said, yeah, I was successful, but I used a FIPS 140-2 algorithm, or I used a FIPS 140-3 algorithm. So it gives you the capability to enforce both. And my suggestion, and I've made this suggestion before, when you code your APIs, I really think you ought to query all of the return codes and reason codes and surface the information that comes back because it may be pertinent to you in the future. So, enforce requires you to use FIPS 140-3, indicate says you can use either one, and he'll tell you which one he used. And then the third option there, hybrid, is kind of like the compat mode before. Hybrid says, yeah, there's some specific applications that need to use FIPS 140-2, and we're going to create another profile in the CryptoZ class that starts with use FIPS 140-2. If you have read access there, you're specifically allowed to use FIPS 140-2 approved algorithms. So that's all very confusing. My recommendation is to set FIPS mode to enforce and provide the highest level of security. And then if you have exceptions, if somebody's using really old technology and they've got to use an old algorithm, you should know about that. And you should specifically enable them to use it as an exception. And by default, not let people use those weaker, older algorithms. So, with that, the last topic that I wanted to talk about is tape encryption. So, way back in 2015, I think, was when IBM first announced pervasive encryption and data set encryption specifically. I can remember Mike Jordan at Share making the comment that for now, data set encryption is limited to DASD data sets. But he said, we understand that you've probably got a lot of tape data out there, and some of that is PII data that needs to be protected, and we understand the requirement. He didn't commit to doing anything about it, but he at least acknowledged that, yeah, tape encryption is probably important to some people.
Great. Greg, sorry, before you go too much further past what you were talking about, we just had a question come in that I want to stop you for a moment.
Yes, ma'am.
Um, it says when you talk about FIPS mode 140-3, do you mean FIPS 143 as opposed to to 140-2 or FIPS 140 slash level 3 as opposed to slash level 2?
Good question because it's confusing. Um, so FIPS 140-2 was the standard, and under FIPS 140-2, you had four levels, one, two, three, and four. FIPS 140-3 is the new level, and under it is still level one, two, three, and four. What's different is level four under FIPS 140-3 is using newer hardware technologies versus level 4 under FIPS 140-2. So, FIPS 140-2 is old, gone. Nothing will ever be certified as FIPS 140-2 compliant again at any level. Everything going forward has to be FIPS 140-3 compliant. Now, within that, EP11, the PKCS 11 support, it being a software module, that would be certified as level 1 under FIPS 140-3. The new Crypto Express cards, they're going to be certified expectedly as level 4, also under FIPS 140-3. So FIPS 140-2 is an old standard incorporating all levels. FIPS 140-3 is the new standard incorporating the same levels, just new technology. So that's the difference. Does that help or does that make it worse? And I need a drink anyway, so it's a good pause point. All
Thanks,
right.
Greg. I will let you know if they
Yep.
pipe back in, but for now I'm going to mark this as answered. And if you do need any more follow-up, we will be emailing. Feel free to get back. Oh, he just wrote back. I think that helps. I can follow up offline. So yes, we will get in touch with you and follow up after the presentation. Thank you so much.
Okay. Yeah. Thanks for the question. IBM said way back in the beginning of time, yep, we understand tape encryption is important, but it wasn't until last year when IBM published the preview announcement for ZOS 3.2 that included that paragraph that says, yeah, we're going to support direct encryption to tape in ZOS 3.2. That said, the formal announcement of ZOS 3.2 has no mention of that support. So, doing a little bit more digging, there is an APAR, a OA66326, that is the APAR that will implement tape encryption in DFSMS. It has not closed yet. So apparently it is still in test. What has closed is APAR OA66305, which are the changes to RAC F that DFSMS tape encryption will require. And specifically, it talks about data set encryption granularity. So, with that said, let's go to the next slide, 15, where it talks about that APAR. What that APAR does is it adds support in RAC F for a new field in the DFP segment where you can specify the types of data sets that you want to have encrypted. So consider that a RACF profile, and my high level qualifier is usually Boyd G. If there was a data set profile out there that said Boyd G.splat splat covers all of my data sets, some of those data sets might be tape data sets, some of those might be PDSEs, some of them might be sequential data sets in terms of the basic and large format. What this capability does is instead of relying on the storage admin profiles to enable encryption for PDSE or sequential data sets, now we can use this encrypt type fields to further control them. So what I might specify in that encrypt type fields for my personal data sets to say in PDSE, if I say in PDSE, what I'm saying is that any data set covered under this profile, those PDSE data sets are eligible to be encrypted using data set encryption. Alternatively, if I say exclude PDSE or EXPDSE, I'm saying, yeah, if there's a profile out here, by default, the way things would work, we would try and encrypt it. But if I specify XPDSE, what I'm saying is, yeah, I don't want my PDSEs to be encrypted. Similarly, for sequential data sets, and I'm not talking about extended format, I'm talking about the basic and large format sequential data sets. I can include or exclude those by type to say all of them are going to be encrypted or none of them are going to be encrypted. And then specific to tape encryption, and this is what's not available yet, is in tape and X tape to say if this profile covers a tape data set, I can say in tape, which says, yeah, that data set should be encrypted. If I say X tape, it's going to be excluded. It's not going to be encrypted. So this encrypt type fields provides some granularity, not just for tape, but for PDSEs and sequential data sets as well. And with that, it turns out there's another APAR, OA68029. I think what happened was when the DFSMS folks realized that the tape support was slipping and wasn't going to be coming quite as soon as they thought, they went ahead and allowed those PDSEs and sequential parameters to work. So those are operational now. It's just the tape data sets. We still can't encrypt them pending DFSMS finishing their testing and publishing that APAR. And this support was refitted all the way back to ZOS 2.5. So if you got an older system, you could take advantage of it. So I think that's everything that I had. The in the handouts, there's some references to all of the ICSF manuals. The systems programming guide covers the ICSF options. The application programmer's guide that covers the changes to the APIs to support that MLKEM and MLDSA. Um, the announcements letters, the preview announcement, as well as the ZOS 3.2 announcement itself. And I've also got a reference to the Z17 announcement in there as well. There is a document out in the IBM community that talks about some of the new capabilities in the new version of ICSF with ZOS 3.2. And then again, here's the reference to that Rex exec that does the hybrid key exchange support. And with that, Sammy, I will turn things back over to you.
Wonderful. Thank you so much again, Greg, for the wonderful presentation. To everybody who joined us, thank you so much. As you can see, Greg put his email address up there. If you have any questions, feel free to contact him directly. Um, Alyssa from New Era, this has been sponsored by New Era Software, of course. So Alyssa from New Era will also be sending you out the opportunity to get a link to this presentation or slides to this presentation or ask any questions you may have that you weren't able to or didn't want to ask during the presentation. We are more than happy to send any information out to you or get you connected with Greg. One more time, thank you everybody for joining us today. It's been a wonderful presentation and we hope to hear back from you.
And I'll add my thanks as well. I'm glad to be back on the Z Exchange. I've missed it. It fills a great gap. It fills a great need in the business.